Hello, and welcome to Architect of Sleep. Tonight, we are not going to a distant star or a forgotten moon. We are coming home to the quiet living body of the earth itself. It is a world that breathes, with an atmosphere that rises and falls. Its heart is a core of silent, liquid fire, and its thoughts are the slow, patient drift of continents. For now, just breathe, let your eyes grow heavy, and allow your mind to soften. Our journey begins now. Let us begin at the very center, a place of impossible heat and pressure. The heart of our planet is not made of stone, but of metal. Deep beneath the ground lies a core of iron and nickel. It is a vast, heavy sphere, a secret metallic center to our world of rock and water. This core was not always there, in its present form. In the early days of our planet, the Earth was a hot, molten ball of rock. Over millions of years, the heaviest materials, like iron, slowly sank towards the center. This process is called differentiation, a slow settling that created the layers of our world. This heavy heart of iron is what gives our planet its weight, its density. It anchors us in space and creates the gravity that holds us to the ground. Without this dense core, our world would be a much lighter and very different place, a heavy anchor in the center of our world. This core is separated into two distinct parts. There is a solid inner core and a liquid outer core that surrounds it. The pressure at the very center is so immense, it forces the iron to be solid, even though it is hotter than the surface of the sun. A solid heart in a sea of liquid fire. The boundary between the solid inner core and the liquid outer core is a strange and quiet place. It is called the Bullen discontinuity. It is a perfect sphere, a smooth transition from solid metal to liquid metal, thousands of miles beneath our feet. A silent border between two different worlds. The temperature there is a quiet, hidden inferno. Scientists estimate the Earth's inner core is over 10,000 degrees Fahrenheit. This incredible heat is partly left over from the planet's formation, 4.5 billion years ago. It is also generated by the slow decay of radioactive elements, a furnace that has been burning since the beginning of time. This inner core is a perfect sphere of solid iron, about the size of the moon. It is spinning, but it seems to be spinning slightly faster than the rest of the planet. It gains a little bit on the surface with each passing year. A slow, independent rotation in the deep dark. This spinning solid core is not perfectly smooth. It has a texture. Scientists believe it may have its own mountains and valleys, all made of solid iron. These are landscapes of unimaginable pressure and heat, forever hidden from our eyes, a secret topography at the heart of the world. Surrounding this solid heart is an ocean of liquid metal. The outer core is a swirling sea of molten iron and nickel. It is this constant slow churning, this vortex of liquid metal, that powers our world's invisible shield, a restless ocean buried thousands of miles beneath your feet. This shield is the Earth's magnetic field. The motion of the liquid iron in the outer core creates powerful electrical currents. These currents generate the magnetic field, which stretches far out into space. It is a vast, invisible bubble that protects us, a silent force born from a spinning sea of metal. This magnetic field is our planet's defense against the sun. The sun constantly sends out a stream of charged particles called the solar wind. The magnetic field deflects most of these particles, preventing them from stripping away our atmosphere. It is a quiet guardian, a shield against the solar storm. This field captures some of those solar particles, trapping them in zones of radiation. These are the Van Allen belts, two donut-shaped rings of energy that surround our planet. They are invisible shields, holding on to the sun's fierce energy. A silent reservoir of captured sunlight. The magnetic poles of our planet are not fixed. They wander slowly over time, moving several miles each year. This is a sign of the slow, chaotic churning of the liquid core far below. The deep engine of our planet is always in motion, always changing, a slow drift of an invisible point. Over very long periods, the magnetic field can do more than just wander. It can flip completely. The north magnetic pole becomes the south magnetic pole, and the south becomes the north. This has happened many times in Earth's history. A great reversal in the planet's deep systems. A quiet flip, recorded in ancient rocks. We have never seen this core, and we never will. We know it is there because of earthquakes. When an earthquake happens, it sends shock waves or seismic waves through the entire planet. By studying how these waves bend and change speed, scientists can map the hidden layers of the Earth. Listening to the echoes from the heart of the world. There are different kinds of these waves, each telling a different story. Primary waves, or P waves, are compression waves. They move like a pulse through a spring, and they can travel through both solid rock and liquid metal. They are the first, fastest messengers from a distant quake. But there is another kind of wave, called a secondary wave or S wave. These waves move from side to side, like a snake. S waves can only travel through solid material. They cannot pass through liquid. Their journey stops when they reach the outer core, a vibration that is swallowed by a hidden sea. By seeing where these S waves are stopped, scientists confirmed that the outer core is liquid. They create a shadow zone on the other side of the planet, a quiet area where the S waves never arrive. It is a shadow that reveals the shape of our liquid heart, an absence of shaking that tells a story. Between the fiery core and the thin crust we live on is a vast, slow-moving layer. This is the mantle, a region of hot, dense rock. It is technically solid, but over millions of years, it flows like a thick, slow river of honey, a river of stone, moving too slowly for us to ever see. This mantle has layers of its own, with different textures and behaviors. The lower mantle is hot and stiff, under immense pressure. The upper mantle is cooler and more brittle, but it contains a special layer, a softer, weaker zone, a hidden softness in the deep stone. This soft layer is called the asthenosphere. It is like a very thick, warm caramel, solid, yet able to flow. It is on this soft, yielding layer that the hard plates of our crust are able to slide. It is the lubricating surface for the slow dance of the continents, a slippery foundation for a moving world. This slow movement is called convection. rock near the hot core heats up, becomes slightly lighter, and rises slowly. Near the cooler crust, it gives up its heat and sinks back down again. This creates huge, slow-turning loops of rock, a planetary engine, turning over millennia. The mantle makes up most of our planet's volume. It is a thick, heavy blanket wrapped around the core. It accounts for more than 80% of the Earth's total mass. We live on just the very thin, cool skin on top of it, a deep, warm foundation for our fragile world. The very top layer of the mantle and the crust together form a rigid shell. This is called the lithosphere. It is this hard, cool layer that is broken into the tectonic plates. It is the solid raft on which we all live, floating on the soft asthenosphere below, a cool, hard shell around a warm, soft heart. The skin of our planet is not one solid piece. It is broken into many huge slabs, called tectonic plates. These plates are like giant rafts of rock, floating on the slow-moving mantle beneath. They are carrying the continents and the ocean floors, a cracked shell on a living planet. There are about a dozen large plates and many smaller ones. Some carry entire continents, like the North American plate. Others are mostly ocean floor, like the vast Pacific plate. They all fit together like a slow-moving puzzle, a jigsaw of stone covering the whole world. These plates are in constant slow motion. They drift across the face of the Earth at about the same speed your fingernails grow, a few inches every year, a movement so slow it is entirely imperceptible. But over millions of years, it reshapes the entire world, a patient, silent dance of stone. This idea of moving continents was once controversial. A scientist named Alfred Wegener first proposed it, noticing how the coastlines of Africa and South America seemed to fit together. He saw the world as a broken puzzle, but it took many years for the science to prove him right. A quiet idea that changed how we see the world. The continents are made of a lighter type of rock, like granite. The ocean floor is made of a heavier, denser rock, like basalt. Because the continents are lighter, they float higher on the mantle than the ocean floor does, like great, rocky ships, floating higher than the sea floor around them. This principle is called isostasy. It is the idea that the rigid crust floats on the softer mantle at an elevation that depends on its thickness and density. A thick mountain range sinks deeper into the mantle, just as a large iceberg sinks deeper into the water, a quiet balance of floating stone. Where these plates pull apart, new crust is born. In the middle of the oceans, there are long underwater mountain ranges called mid-ocean ridges. Here, magma from the mantle rises to fill the gap and hardens into new seafloor, the Earth creating new skin for itself in the deep sea. This process is happening right now, in the middle of the Atlantic Ocean. The Mid-Atlantic Ridge is a great seam running down the center of the ocean. North and South America are slowly moving away from Europe and Africa, and the ocean is growing wider by an inch or two each year. A slow, silent spreading in the dark water. And where the plates push together, mountains are born. The immense pressure between two colliding continents can cause the rock to buckle and fold. It is forced slowly upwards, creating great mountain ranges. The Himalayas are still growing taller today from this slow collision, stone reaching for the sky over millions of years. Sometimes one plate slides beneath another. This is called subduction. An oceanic plate, which is denser, will slide down into the hot mantle beneath a continental plate. As it sinks, the rock melts, creating volcanoes along the coast, the earth swallowing its own skin to be born again as fire. This zone of subduction is a place of great activity. The Ring of Fire around the Pacific Ocean is a huge chain of volcanoes and earthquakes. It is caused by the massive Pacific Plate sliding beneath the continents that surround it, a circle of fire marking the edge of a great plate. There is a third type of boundary between plates. Sometimes two plates do not collide or pull apart, but slide past each other horizontally. This is called a transform fault. The pressure builds along the fault line and is released in sudden, sharp movements. Two giant slabs of rock, grinding slowly past one another. The San Andreas Fault in California is a famous example of a transform boundary. It marks the line where the Pacific Plate is sliding north, past the North American Plate. The land on one side of the fault is moving in a different direction from the land on the other. A quiet, steady creep, punctuated by sudden jolts. All the continents we know today were once joined together. About 300 million years ago, there was a single supercontinent called Pangaea. It was a vast landmass surrounded by a single global ocean. The slow dance of the plates eventually pulled it all apart. A memory of a world that was one. The ground beneath you feels solid and still, but it is not. Earthquakes are a reminder of the moving plates. They happen when two plates get stuck, and the pressure builds up. When the pressure is finally released, the ground shakes, a sudden shudder from the deep machinery of the world. The point on the fault where the earthquake begins is called the hypocenter, deep underground. The point on the surface directly above it is called the epicenter. The shaking is strongest at the epicenter and spreads out from there like ripples in a pond. A wave of energy spreading through the stone. Not all earthquakes are felt by us. Thousands of tiny quakes, or called microquakes, happen around the world every day. They are too small for us to notice, but sensitive instruments can detect them. They are the constant, tiny adjustments of our planet's crust. A quiet tremor in the deep rock. Another reminder of the planet's inner heat is a volcano. It is a place where molten rock, or magma, finds a path to the surface. When it erupts, it releases lava, ash, and gases. It is a violent event, but it is also how new land is created. The Earth's fiery breath made visible. Sometimes a volcano breathes out more than just lava. It can release a superheated cloud of ash, gas and rock, called a pyroclastic flow. This cloud is heavier than air, and it rushes down the side of the mountain at incredible speed. It is a silent, grey avalanche of immense heat. A hot, fast-moving shadow on the side of the mountain. Volcanic eruptions can also trigger massive mudflows. The intense heat can melt snow and ice on the mountain, creating a torrent of water. This water mixes with volcanic ash and debris, forming a thick, heavy slurry called a lahar. It flows down river valleys like wet concrete, a grey river of mud, reshaping the land in its path. There are different kinds of volcanoes shaped by the type of magma they contain. Shield volcanoes are formed by thin, runny lava that flows for long distances. This creates broad, gently sloping mountains, like the ones in Hawaii, a wide, low mountain built by rivers of liquid rock. The lava from these shield volcanoes has different textures. Sometimes it cools into a smooth, ropey surface called pahoho. In other places, it cools into a rough, jagged, blocky surface called aa. Both are made of the same material. They just cooled in different ways. Two different faces of the same stone river. Other volcanoes are steep and cone-shaped. These are called stratovolcanoes, or composite volcanoes. They are built up from many layers of sticky, thick lava and explosive ash. They often have violent eruptions, like Mount Vesuvius or Mount Fuji, a tall, steep cone with a fiery temper. When a massive stratovolcano erupts, it can empty the magma chamber deep beneath it. The mountain can then collapse into the empty space, creating a huge bowl-shaped depression. This is called a caldera, a vast crater that tells the story of a colossal explosion, a giant scar left by an ancient eruption. Not all volcanoes are explosive mountains. In some places, lava flows gently from long cracks in the ground. These are called fissure vents. They can create vast plains of black volcanic rock, called flood basalts. These events can cover huge areas in new stone, rivers of fire reshaping the land. Sometimes magma does not reach the surface at all. It can push up the rock layers above it, creating a dome-shaped mountain. These are called laccoliths. They are like a volcano that never quite happened, a bulge in the Earth's skin, a hidden intrusion of molten rock. When lava erupts underwater, it cools very quickly. The surface of the lava hardens into a crust, while the inside is still molten. The pressure of the flowing lava breaks through the crust and creates a new rounded shape. This forms what is called pillow lava, a lumpy pillow-like texture on the deep sea floor. Stone pillows on the bed of the ocean. The tallest mountain on Earth, measured from its base, is not Mount Everest. It is Mauna Kea, a volcano on the island of Hawaii. Most of its huge body is hidden beneath the Pacific Ocean. From its base on the seafloor to its peak, it is far taller than Everest, a giant mountain hiding in the sea. Hawaii itself is the product of a hotspot. This is a place where a plume of extra hot rock from deep in the mantle rises up. As the Pacific Plate moves over this stationary hotspot, a chain of volcanic islands is created. The oldest islands are dormant, carried far away from the hotspot. A chain of islands, marking the slow passage of a plate. The stone of our world is in a constant slow cycle of change. This is the rock cycle. Igneous rock is formed from cooled magma, like granite or basalt. It is the fresh, new stone of the planet. Rock born from fire. The texture of this igneous rock tells a story. If the magma cools slowly, deep underground, large crystals have time to form. This creates a coarse-grained rock like granite. If the lava cools quickly on the surface, the crystals are tiny, creating a fine-grained rock like basalt. a story of time written in crystal size. Over time, wind and water wear down this rock. They break it into tiny pieces, sand and silt. These particles are washed into rivers and settle at the bottom of lakes and oceans. Over millions of years, the weight of layers above them presses them together, forming sedimentary rock like sandstone or shale, rock born from pressure and time. These sedimentary rocks often form invisible layers, called strata. Each layer represents a different period of deposition, a different chapter in the Earth's history. You can see these stripes of time in the walls of canyons, a book with pages made of stone. If this rock is buried even deeper, it is changed by intense heat and pressure. The minerals inside it are rearranged, creating a new kind of rock. This is metamorphic rock, like marble, which was once limestone, or slate, which was once shale. Rock that has been transformed into something new. This transformation can create beautiful patterns. The pressure can align the minerals into bands, creating a striped rock called gneiss. It is a memory of the immense forces that squeezed and cooked the rock, deep within the Earth's crust. A quiet ripple in a solid stone. This cycle is endless. Metamorphic rock can be melted back into magma to start the cycle again. Sedimentary rock can be pushed to the surface and eroded. It is a slow, planetary system of recycling, turning stone into new stone over and over again. A silent, patient transformation in the crust. The rocks of our world are made of minerals. A mineral is a naturally occurring solid with a specific chemical recipe and a crystal structure. Quartz is one of the most common, a hard, glassy mineral that often forms beautiful six-sided crystals, a simple, perfect geometry born in the earth. Not all stones have the same strength. A soft mineral like talc can be scratched with a fingernail, while a hard mineral like a diamond can scratch almost anything else. Scientists use a simple scale of hardness to tell them apart, from 1 to 10. It is a way of understanding the quiet resilience of a stone, a simple number that tells a story of inner strength. Minerals also break in their own special ways. Some break along flat, smooth planes, a property called cleavage. The mineral mica, for example, cleaves into perfect paper-thin sheets. It is a memory of its internal crystal structure, a clean break along an invisible line. Other minerals do not have this property. When they break, they fracture along curved or irregular surfaces. Obsidian, which is volcanic glass, breaks with a beautiful curved fracture, like the inside of a seashell. It creates an edge that is sharper than any blade, a smooth curved scar on a piece of black glass. Let us rise now, from the deep rock to the surface. The ground we walk on, the soil, is a thin and precious layer. It can take 1,000 years for nature to create just 1 inch of topsoil. It is a complex blend of rock particles, air, water, and living things. The fragile skin of the living world. This soil is not a single uniform thing. It has layers. These are called soil horizons. At the top is the O horizon, made of fresh, decaying organic matter, like fallen leaves. Below that is the A horizon, the rich, dark topsoil where most roots grow, a layered blanket for the surface of the world. Below the topsoil is the B horizon, or subsoil. It has less organic matter and is made of clay and mineral deposits that have washed down from above. And below that is the C horizon, which is mostly broken up rock from the solid bedrock that lies beneath. A slow transition from life back to stone. The texture of soil depends on its particles. Sandy soil has large particles and feels gritty. Water drains through it quickly. Clay soil has very fine particles and feels sticky. It holds water for a long time. The best soil for plants is a mix of both, called loam, a perfect balance of grit and softness. This soil is a city of invisible life. A single teaspoon of healthy soil contains billions of microbes, bacteria, and fungi. They are the decomposers, breaking down dead plants and animals. They turn death back into the simple nutrients that create new life. A silent, tireless army of recyclers. There are other, larger engineers in the soil. Earthworms are constantly tunneling through the ground. They eat soil and organic matter, and their castings enrich the earth. Their tunnels create channels for air and water to penetrate deep into the soil. A quiet gardener, ploughing the dark earth. In dry desert lands, the soil has a different kind of life. It is covered by a thin, dark crust called cryptobiotic soil. This crust is a living community of cyanobacteria, lichens and mosses. It holds the fragile desert soil together and prevents it from blowing away in the wind. A living shield on the face of the desert. Beneath the soil, a hidden world connects the trees. A vast, intricate network of fungal threads, called mycelium, links the roots of the forest. It is like a secret internet for the trees. They can use it to share water and nutrients. A hidden commonwealth of roots and threads. Through this network, trees can talk to each other. They send chemical signals, warning of insect attacks or dry conditions. A large, older mother tree can even send food to smaller seedlings growing in her shade. The forest is not a collection of individuals, but a single, connected community. A silent conversation happening under your feet. Some life exists even deeper, far from the soil and the sun. Deep within the cracks of the Earth's crust, miles below the surface, live tiny microbes. These are extremophiles, lovers of extreme conditions. They survive on chemicals found in the rock and water that seeps down from above. A hidden biosphere, deep within the stone. Let us now travel to the world of water, the hydrosphere. Most of the Earth's surface is not land, but ocean. This vast body of salt water covers more than 70% of our planet. It is so deep and wide that it appears as a great blue mystery from space. A world of water on a planet of rock. The ocean is salty because of the land. As rivers flow over rocks, they slowly dissolve tiny amounts of mineral salts. These salts are then carried to the sea. When water evaporates from the ocean surface, the salt is left behind. Over billions of years, this process has made the ocean salty, a slow seasoning from the continents. The saltiness of the ocean is not the same everywhere. Near the poles, where ice is forming, the water becomes saltier. This is because the salt is left behind when the water freezes. In places where large rivers empty into the sea, the water is less salty, diluted by the fresh water. A shifting pattern of salt, across a global sea. All the water on our planet, in the oceans, rivers and clouds, is ancient. It is the same water that has been here for billions of years. It may have first arrived on icy comets and asteroids that crashed into the young Earth, a gift from the cold, dark void. There is a fixed amount of water on Earth. It is constantly moving in a great slow cycle. The water in your body today was once in a cloud, in a river, in a glacier, or inside a dinosaur. It is on an endless journey, a single drop of water on a voyage through time. This journey is a quiet planetary breath. The sun's warmth gently lifts water from the ocean's surface, turning it into invisible vapor. This is evaporation. It rises high into the cool air. There, it condenses back into tiny droplets, forming the clouds. Water remembering how to fly. The oceans are not still. They are in constant motion. The tides, the slow daily rise and fall of the sea level, are a rhythm for the planet. They are caused by the gentle gravitational pull of the moon, and to a lesser extent, the sun, the ocean breathing in and out twice a day. The moon's pull is just strong enough to lift the water, but not the land. As the Earth spins, a bulge of water is pulled towards the moon. Another bulge forms on the opposite side of the planet. These moving bulges create the high tides, a silent, invisible hand stirring the deep. Twice a month, when the sun, moon, and Earth are all in a line, the sun's gravity adds to the moon's. This creates extra high tides and extra low tides. These are called spring tides, a time of greatest difference between high and low water, a deep breath for the ocean. When the sun and moon are at right angles to each other, their gravitational pulls work against each other. This creates weaker tides, with less difference between high and low water. These are called neap tides, a time of quiet, shallow breaths for the ocean. There are also great rivers within the ocean. These are ocean currents, moving vast amounts of warm or cold water around the globe. The Gulf Stream, for example, carries warm water from the tropics up to northern Europe. It acts like a huge heating system for the planet, a slow, warm river in the cold, dark sea. These currents are part of a massive, global system. It is called the thermohaline circulation, or the Great Ocean Conveyor Belt. It is driven by differences in temperature and saltiness. Cold, salty water is dense, so it sinks in the polar regions and flows along the ocean floor towards the equator. A slow, deep circulation that connects all the oceans. This giant, slow-moving current takes about 1,000 years to complete one full circuit. It is a vital part of our planet's climate system, distributing heat around the globe. It is a slow, silent engine, moderating the Earth's temperature. 1,000-year journey for a single drop of water. The deepest parts of the ocean are a world of extremes. The Mariana Trench is the deepest point on Earth. The pressure there is over 1,000 times greater than at the surface. It is a world of total darkness, crushing weight, and profound silence. A quiet, hidden scar on the ocean floor. The floor of the deep ocean is not all trenches and mountains. Much of it is a vast flat plain, called the abyssal plain. It is covered in a thick layer of fine sediment, the marine snow that has been falling for millions of years. It is one of the flattest, smoothest places on Earth. A vast, empty desert under 3 miles of water. From this plain, underwater mountains can rise. These are called seamounts. They are volcanoes that rose from the ocean floor, but never broke the surface. They are oases of life in the deep sea, providing a hard surface for corals and sponges to grow on. Lonely mountains in the deep, dark water. Some of these seamounts have flat tops, as if they were sliced off. These are called gyres. They were once volcanic islands that rose above the sea. Over millions of years, the waves eroded their tops flat, and then they slowly sank back beneath the surface, a flat-topped mountain remembering the sky. The creatures that live in the deep sea are built for this pressure. Their bodies are soft and gelatinous, mostly made of water. Because water is incompressible, the pressure inside them is equal to the pressure outside. They are not crushed. They belong to the deep, a life adapted to a heavy, liquid world. In the total darkness of the deep, there is life without sunlight. Hydrothermal vents are like underwater geysers, spewing superheated, mineral-rich water from inside the earth. Around them, strange ecosystems thrive. Bacteria get their energy from chemicals like hydrogen sulfide, and they form the base of the food chain, an oasis of life, fueled by the Earth's inner heat. There are different kinds of these vents. Black smokers release water that is rich in dark, iron sulfide minerals. White smokers release cooler water, rich in lighter-colored minerals like barium and silicon. Both create strange, chimney-like structures on the seafloor. Towers of stone growing in the dark. Many deep-sea creatures create their own light. This is called bioluminescence. They use chemical reactions in their bodies to produce a cold glow. They use this light to attract prey, to find mates, or to startle predators in the eternal darkness. A silent language of cold fire. There is a strange place in the ocean called the Sofar Channel. It is a layer of water about half a mile down, where the speed of sound is at its lowest. Sound waves that enter this channel can become trapped, traveling for thousands of miles with very little loss of energy, a natural sound channel in the heart of the ocean. Whales may use this channel to communicate over vast distances. Their low-frequency songs can travel across entire ocean basins, trapped within this quiet layer. It is a hidden highway for sound, a private line for the giants of the deep, a whisper that can cross an ocean. Much of the deep ocean floor is covered in a soft, fine mud. This is called marine snow. It is a continuous shower of organic material, falling from the upper waters. It is made of the remains of tiny plankton, their shells and bodies slowly drifting down. A gentle, endless snowfall of ancient life. The great mass of the ocean helps to keep our planet's temperature stable. Water can absorb a huge amount of heat without changing its own temperature very much. The oceans act as a giant heat sink, soaking up the sun's energy during the day and in the summer, and releasing it slowly at night and in the winter. A vast liquid blanket, moderating the world. The sound of waves on a shore is a deeply calming rhythm. A wave is not water moving across the ocean, but energy moving through the water. The water itself mostly just moves up and down. As the energy reaches the shallow shore, the wave rises up and then breaks, the ocean sighing as it touches the land. The sand on a beach is the final product of a very long journey. It often begins as hard rock, high in the mountains. Over thousands of years, wind and rain break the rock down into smaller pieces. Rivers carry these pieces to the sea, and the endless motion of the waves tumbles them until they are tiny, smooth grains, mountains turned into dust by time and water. Not all sand is made of rock. In some tropical places, the beaches are made of fine white sand. This sand is the ground-up skeletons of coral and the shells of tiny sea creatures. Some fish even help create it by eating coral and excreting fine grains of sand. A beach made of the ghosts of tiny animals. Some beaches even have black sand. This sand is made from volcanic rock, like basalt or obsidian. It is born from the fire of a volcano, and then ground into fine grains by the power of the sea. A dark, glittering shore, born from fire and water. Let us move from the oceans to the frozen parts of our world, the cryosphere. The vast ice sheets of Antarctica and Greenland hold most of the Earth's fresh water. They're like frozen continents, miles thick in some places. They are a record of past climates, trapped in layers of ice, a white desert of profound cold and silence. These ice sheets are so heavy that they press down on the land beneath them. In some places, the weight of the ice has pushed the bedrock of Antarctica far below sea level. If the ice were to melt, much of the continent would be a vast, shallow sea, a continent held down by a blanket of ice. These ice sheets may look still, but they are flowing. Glaciers are like very slow-motion rivers of ice. Gravity pulls them down mountains and through valleys. They move only a few inches to a few feet per day, but with an unstoppable, grinding force, a patient, crushing journey of ice. As glaciers move, they make sounds, deep groans, loud cracks, and a constant, quiet grinding. It is the sound of immense weight in slow motion. If you could speed up time, a glacier would roar like a great river. The slow, deep voice of ancient ice. As glaciers move, they carve and shape the land. They pluck rocks from the ground and drag them along, scouring the landscape. They carve deep U-shaped valleys and leave behind piles of rock and debris called moraines. Many of the world's most dramatic landscapes were sculpted by ancient ice, a slow, cold chisel, shaping the stone. Sometimes a glacier carves a sharp, pointed mountain peak. When several glaciers erode a mountain from different sides, they can leave behind a pyramid-shaped peak called a horn. The Matterhorn in the Alps is a famous example, a mountain sharpened by ice. Sometimes a glacier carves a valley so deep that it reaches the sea. When the ice melts and retreats, the sea floods the valley. This creates a deep, narrow inlet with steep side, called a fjord. They are silent, deep waterways, ghosts of the ancient ice, a valley carved by ice, now filled with sea. In some parts of the world, the ground itself is permanently frozen. This is permafrost. It is a layer of soil, rock, or sediment that remains frozen for at least 2 years in a row. The surface layer may thaw in the summer, but the deep ground remains like stone, a hidden layer of ice holding the land together. Every snowflake that falls is a tiny work of art. As a droplet of water freezes high in a cloud, it forms a 6-sided ice crystal. As it falls, it tumbles through different temperatures and levels of moisture. This causes its 6 arms to grow in a unique and complex pattern. A tiny, perfect jewel of ice, gone in a moment. When snow accumulates on the ground, it acts as an insulating blanket. A thick layer of snow can protect the ground and the roots of plants from the deep cold of the winter air. Small animals can even tunnel through the snow, living in a hidden world between the snow and the earth, a soft white quilt for the sleeping land. Large pieces of glaciers sometimes break off and fall into the sea. This is called calving, and it creates icebergs. Most of an iceberg's mass, about 90% of it, is hidden beneath the surface of the water. They drift with the ocean currents, slowly melting as they travel, a floating mountain of ancient ice. In the polar oceans, new ice is born every winter. As the seawater gets very cold, tiny needle-like ice crystals form. This is called fragile ice. These crystals clump together, forming a soupy slush on the ocean surface, the sea beginning to turn solid. As the slush continues to freeze, it can form into round, flat pieces of ice. These are called pancake ice. The edges are raised from bumping into each other in the moving water. They look like a strange, floating mosaic on the surface of the cold sea, a field of icy lily pads on a polar ocean. Now, let us rise into the air, the atmosphere. The air you breathe is mostly not oxygen. It is made of nearly 80% nitrogen, a quiet, neutral gas. Oxygen makes up only about 21%. The nitrogen acts as a buffer, softening the power of the oxygen, making the air gentle enough for life. A calm, invisible ocean all around us. The remaining 1% of the air is made of other things. There is a small amount of argon, a noble gas that does nothing. And there are trace amounts of other gases, like carbon dioxide, which plants need to live, a complex recipe for the air we breathe. The atmosphere is not a single entity. It has layers. We live in the troposphere, where all the weather happens. Above that is the stratosphere, a calm, clear layer where jets fly. Higher still are the mesosphere and the thermosphere, where the air thins out into the blackness of space, a series of invisible blankets wrapping the world. The boundary between the atmosphere and space is not a sharp line. The air just gets thinner and thinner and thinner. Scientists have an imaginary line called the Kármán line, about 62 miles up. This is the point where they say the atmosphere ends and space begins, a gentle fade into the void. High in the stratosphere, there is an invisible shield. This is the ozone layer, a thin blanket of special oxygen molecules. Each molecule has 3 oxygen atoms, instead of the usual 2. This layer absorbs most of the sun's harmful ultraviolet radiation, protecting all life below. A fragile shield for a living world. The daytime sky is blue because of a trick of the light. Sunlight is made of all the colors of the rainbow. As it enters our atmosphere, the air molecules scatter the blue light more effectively than the other colors. This scattered blue light comes at us from every direction, filling the sky. A vast ceiling painted by tiny particles. At sunrise and sunset, the sky turns red and orange. This is because the sunlight has to travel through more of the atmosphere to reach our eyes. By the time it gets to us, most of the blue and green light has been scattered away. Only the longer wavelengths of red and orange light remain. The sky blushing good night. The air around you has weight. A column of air stretching from the ground to the edge of space weighs about 14 pounds on every square inch of surface. We don't feel this immense pressure because we are used to it, and the air inside our bodies pushes out with the same force. An invisible weight we carry without effort. Wind is simply air in motion. It is caused by differences in air pressure, which are usually created by differences in temperature. Air flows from areas of high pressure to areas of low pressure. The spinning of the Earth then bends these winds into curving patterns, the atmosphere trying to find its own balance. This bending of the wind is called the Coriolis effect. Because the Earth is a spinning sphere, winds in the northern hemisphere are deflected to the right, and winds in the southern hemisphere are deflected to the left. This is why hurricanes spin in different directions on either side of the equator, a silent, invisible twist caused by a turning world. There are great predictable wind patterns that circle the globe. Near the equator are the doldrums, a region of calm, light winds. Further north and south are the trade winds, which once powered sailing ships across the oceans. These are all part of a vast system of atmospheric circulation, a planet-sized system of quiet flowing air. High above us, there are fast-flowing rivers of air. These are the jet streams. They are narrow bands of very strong wind in the upper atmosphere. They snake their way around the planet and have a powerful influence on our weather patterns down below. Invisible rivers racing through the upper air. A cloud is a floating collection of countless tiny water droplets, or ice crystals. They are so small and light that even the gentlest upward currents of air can hold them aloft. They are visible whispers of the water cycle, drifting across the sky, a piece of the ocean learning to fly. For a cloud to form, the water vapor needs something to condense onto. It needs a tiny particle, like a speck of dust, a grain of pollen, or a bit of salt from the sea. These are called condensation nuclei. Every single droplet in a cloud has a tiny, solid heart, 1 million tiny anchors for a floating cloud. Some clouds are thin and wispy, like a painter's brush stroke. These are cirrus clouds, and they exist very high in the atmosphere, where it is freezing cold. They are made not of liquid water, but of tiny, delicate ice crystals. They often signal that the weather is about to change, like frozen ghosts drifting across the blue. Sometimes these high ice crystals can play tricks with the light. They can create a perfect circle of light around the sun or the moon. This is called a halo. It is like a rainbow, but formed by refraction through ice crystals instead of raindrops. A ring of pale light in the thin, high air. On either side of the sun, you might also see bright spots of light. These are called sundogs. They are also caused by light passing through ice crystals in high, thin clouds. They are like two phantom suns, quietly flanking the real one, a silent echo of the sun in the cold air. Other clouds are like soft white sheets that cover the whole sky. These are stratus clouds. They are low, grey, and featureless. They often bring a light drizzle or snow. They are the clouds of a quiet, overcast day, a soft grey blanket pulled over the world. When a stratus cloud is on the ground, we call it fog. It is a cloud that you can walk through, a place where the air itself is filled with tiny floating water droplets. It softens all sounds and blurs the edges of the world. A quiet, grey dream that has settled on the land. Other clouds are tall and towering, like mountains in the sky. These are cumulonimbus clouds, the clouds of thunderstorms. They are full of powerful updrafts and downdrafts. They can grow so tall that their tops reach the bottom of the stratosphere, a visible sign of the atmosphere's power. Sometimes strange clouds form in the shape of a lens or a saucer. These are lenticular clouds. They often form on the downwind side of mountains. As the air flows over the mountain, it creates a standing wave, and the cloud forms at the crest of the wave. A smooth, still cloud in a fast-moving wind. Sometimes you might see pouch-like clouds hanging from the base of a thunderstorm. These are mammatus clouds. They are formed by sinking cold air, creating a strange, lumpy texture on the underside of the cloud. They are a sign of very turbulent, unstable air, a bumpy, textured ceiling in the sky. Sometimes after the rain, the light creates a perfect arc of color. A rainbow is born when sunlight shines through raindrops. Each tiny drop of water acts like a prism, bending the light and splitting it into its separate colors. To see it, the sun must be behind you and the rain in front of you, a temporary bridge made of light and water. A double rainbow is a reflection. The second fainter rainbow that sometimes appears outside the first one is caused by the light reflecting twice inside each raindrop. Because of this second reflection, the order of the colors in the second rainbow is reversed, an echo of light in the falling rain. Lightning is a giant spark of static electricity in the atmosphere. Inside a storm cloud, tiny ice particles and water droplets rub against each other, building up huge electrical charges. When the charge becomes strong enough, it is released as a brilliant flash of lightning, a sudden silent crack in the sky. Thunder is the sound that lightning makes. The lightning bolt is incredibly hot. It heats the air around it in an instant. This superheated air expands explosively, creating a powerful shockwave. That shockwave is what we hear as thunder, the slow sound, chasing the fast light. Above the powerful thunderstorms, a strange and ghostly light can appear. For a fraction of a second, huge dim flashes of red light can erupt towards space. These are called sprites. They are a form of high-altitude lightning. A secret and silent light show far above the clouds, a fleeting red ghost in the upper atmosphere. The sound of rain has a special quality. It is not one sound, but millions of tiny individual sounds. Each drop hitting a surface, a leaf, a roof, or the ground, creates its own small note. Together, they form a calming, gentle hum, a white noise made by nature, a quiet music played by the falling sky. In the dry air of the desert, some rain never reaches the ground. It falls from a cloud, but the air below is so warm and dry that the raindrops evaporate in mid-air. These wispy streaks of falling rain that disappear are called virga. It is the ghost of a rain shower. A soft grey veil that never touches the earth. There is a special scent that comes with the first rain after a long dry spell. It is called petrichor. It is the smell of oils released by plants and chemicals made by soil bacteria. The falling rain traps these scents in tiny air bubbles, which then float up and burst, releasing the fragrance into the air, a quiet perfume released by the thirsty earth. Far to the north and south, the sky can dance with light. The aurora borealis and aurora australis are a gift from our magnetic field. When charged particles from the sun are guided by the field towards the poles, they collide with atoms in the upper atmosphere. These atoms then glow in curtains of green, pink, and violet, a silent, colourful symphony in the night sky. The Earth does not spin straight up and down. It is tilted on its axis, a permanent lean of about 23.5 degrees. It is this simple tilt that gives us our seasons. As we orbit the sun, different parts of the planet lean towards the sunlight, creating summer, and away from it, creating winter, the gentle rhythm of the passing year. This tilt is not perfectly stable. The Earth's axis has a slow wobble, like a spinning top that is starting to slow down. This is called precession. It takes about 26,000 years for the axis to complete one full wobble, a slow, silent wobble over a vast expanse of time. Because of this wobble, our North Star changes over time. Today, the axis points towards Polaris. But in the time of the ancient Egyptians, it pointed to a different star called Thuban. In 12,000 years, it will point towards the bright star Vega, a slow change of focus in the night sky. The Earth's orbit around the Sun is not a perfect circle. It is a gentle ellipse. This means that sometimes we are slightly closer to the Sun, a point called perihelion, and sometimes we are slightly farther away, a point called aphelion. This has a small but measurable effect on our climate, a slow, yearly breath in our path around the Sun. These long, slow changes in the Earth's orbit, tilt, and wobble are called Milankovitch cycles. They are believed to be the main driver of the ice ages, the long periods of cold and warmth that have marked our planet's history. They are the great slow pacemakers of the Earth's climate, a cosmic rhythm that shapes our world over eons. The world is always turning, but you cannot feel it. At the equator, the ground beneath you is moving at over 1,000 miles per hour. At the poles, the speed is nearly zero. It is a constant, steady motion, like a perfectly balanced spinning top. A silent, endless waltz through the darkness of space. And something is always holding you gently to its surface. This is the force of gravity, a constant, invisible embrace. It doesn't pull you down harshly. It simply tethers you. It keeps your feet on the ground and holds the very air you breathe from drifting away into space. A quiet promise that you belong here. The Earth's gravity is not perfectly uniform because the planet is not a perfect sphere, and its mass is not distributed evenly. There are tiny variations in the strength of gravity. On top of a large mountain, gravity is slightly weaker. It is a map of invisible hills and valleys in the force that holds us, a subtle texture in an unseen field. Let us now turn to the world of life, the biosphere. The green in every leaf is working a quiet magic. Photosynthesis is the process that powers almost all life on Earth. Plants use the energy from sunlight, water from the soil, and carbon dioxide from the air to create their own food. A silent factory turning light into life. As a byproduct of this process, plants release oxygen. The oxygen that fills our atmosphere and that we need to breathe was created by billions of years of plant life. We are in a silent partnership with the green things of the world. We breathe out what they need, and they breathe out what we need, a shared atmosphere, a shared life. There are trees on Earth that were alive when the pyramids were being built. The bristlecone pines of California are some of the oldest living things on the planet. Some are nearly 5,000 years old. They survive in a harsh, dry environment by growing incredibly slowly. Ancient beings, watching the centuries pass like seasons. The tallest living things on Earth are the coast redwoods, also in California. They can grow to be over 350 feet tall. They create their own climate, capturing moisture from the fog that rolls in from the Pacific Ocean. Their thick, spongy bark protects them from fire. Silent green giants, touching the clouds. A seed is a masterpiece of patience. Inside its hard shell, it holds a tiny sleeping embryo and a packed lunch of nutrients. It can wait for days, or even thousands of years, for the right conditions of water and warmth. Then it will awaken and begin to grow, a small vessel of potential, waiting for its moment. On old walls and rocks, you can find a soft green carpet. Moss is one of the most ancient and simple plants. It has no flowers, no seeds, and no true roots. It absorbs water and nutrients directly through its tiny leaves, like a living sponge, a quiet, humble green on the face of the stone. The opening of a flower is a slow, graceful ballet. It is a carefully controlled process, driven by changes in water pressure within its cells. Some flowers open with the morning light and close again at dusk. This is called nyctinisty. It is a daily rhythm of unfurling and resting, a silent bloom in the warm sun. This blooming is not just for beauty, it is an invitation. The bright colors and sweet scents of flowers attract pollinators, like bees and butterflies. As they feed on the nectar, they carry pollen from one flower to another. This is how plants create the seeds for the next generation, a delicate partnership between the moving and the still. In winter, when food is scarce and the world is cold, some animals disappear into a deep sleep. Hibernation is a state of suspended animation. A hibernating animal's heart rate slows down dramatically. Its breathing becomes shallow, and its body temperature drops close to freezing. A long, slow breath held until spring. Many birds do not stay for the winter. They undertake incredible journeys of migration. The Arctic tern flies from the Arctic to the Antarctic and back again each year, a journey of over 40,000 miles. They chase the summer, living in endless daylight, a life spent following the sun. These birds navigate using a remarkable set of senses. They use the position of the sun and the stars. They can also sense the Earth's magnetic field, using it like an internal compass. They follow the same invisible pathways, year after year, a silent map carried in a tiny mind. Sea turtles also travel vast distances to find their way home. A female loggerhead turtle will swim thousands of miles across the open ocean to return to the exact same beach where she was born. She does this to lay her own eggs. How she navigates this journey is still a quiet mystery, an ancient instinct, a journey across the blue. On a warm summer evening, you may see tiny blinking lights in the grass. Fireflies are not actually flies. They are beetles. They create their light through a chemical reaction in their bodies, a process called bioluminescence. It is a cold light, created with almost perfect efficiency, a silent, luminous conversation in the dark. Deep in the ocean, a sound travels for hundreds of miles. The songs of the humpback whale are complex, haunting, and can last for hours. Only the male whales sing. All the males in one population will sing the same evolving song, but the song is different in each ocean, a deep, lonely music in the vast water. The purr of a cat is a quiet mystery. It is not made in the same way as other sounds. It is a continuous vibration, created by the muscles of the larynx, on both the inhale and the exhale. The frequency of the purr is thought to promote healing in bones and tissues, a soft vibrating engine of contentment. The world moves at many different speeds. A snail glides on a muscular foot, leaving a silvery trail of slime. It moves with a slow, steady determination. It experiences the world on a different timescale, where a single garden is a vast and complex kingdom, a patient journey across a single leaf. Floating in the ocean are creatures that are ancient and simple. Jellyfish have no brain, no heart, and no bones. They are more than 95% water. They drift with the currents, pulsing their bell gently to move. They have existed, virtually unchanged, for over 500 million years. A dreamy, watery ghost from a forgotten time. The foundation of most ocean life is almost invisible. Plankton are tiny, often microscopic, organisms that drift in the water. There is phytoplankton, which are like tiny plants, and zooplankton, which are tiny animals. They are the food for almost everything in the sea, from small fish to the largest whales, a silent, drifting forest that feeds the world. Our planet is not a perfect sphere. As it spins, it bulges slightly at the equator and is flattened at the poles. It is what scientists call an oblate spheroid. This means if you were to measure it, it is slightly wider than it is tall, a small imperfection on a planetary scale. There is a magical time just after sunset and just before sunrise. It is called the blue hour. The sun is below the horizon, but its light is still scattered by the upper atmosphere. This light is predominantly blue, and it bathes the world in a soft, deep, and peaceful color, a quiet monochrome moment between day and night. During a total solar eclipse, a strange quiet falls over the land. The moon passes directly in front of the sun, and the day turns to a deep twilight. The birds stop singing, the temperature drops, and the air grows still. For a few minutes, the world holds its breath. The sun's fiery crown, made visible in the sudden dark. The Earth itself produces a constant low-frequency hum. It is far too low for human ears to hear. It is thought to be caused by the constant gentle motion of the oceans, the waves and tides interacting with the seafloor. The planet is always vibrating, always humming to itself, a deep, inaudible song of a living world. The story of past life is written in stone. A fossil is formed when a plant or animal dies and is quickly buried in mud or sand. Over millions of years, minerals in the water seep into the remains, replacing the organic material. It is a slow process of turning life into rock, a silent echo of a long-vanished creature. Sometimes a fossil is not the creature itself, but a trace it left behind. A footprint in ancient mud can harden into rock, preserving a single moment in time. These are called trace fossils, and they tell us how ancient creatures moved and lived. A ghost of a footstep, preserved for 1,000,000 years. In some parts of the world, there are caves made not of rock, but of ice. They are formed within glaciers. Meltwater carves tunnels and chambers into the dense, ancient ice. The light that filters through the thick ice is a deep, magical blue. It is like entering the heart of the glacier, a temporary palace of frozen water. In the deepest, darkest caves, stone can grow. Water-rich and dissolved calcite drips slowly from the ceiling. Each drop leaves a tiny mineral deposit. Over thousands of years, these deposits grow into long fingers of stone called stalactites, hanging from the ceiling. Stone icicles growing over centuries. Where the drips land on the cave floor, they build up another structure. These are called stalagmites, growing up to meet the stalactites. Sometimes they meet in the middle, forming a single solid column of stone, a slow, patient meeting in the dark. Sound travels through the air at a steady pace, about 767 miles per hour. It is much slower than light. This is why you see lightning flash almost instantly. But the sound of the thunder takes several seconds to reach you. You can count the seconds to know how far away the storm is. A race between the seen and the unseen. The water that makes up most of your body is ancient. It has been part of the Earth's water cycle for billions of years. It has been in clouds, rain, rivers, and oceans. It has been inside countless other living things before you. You are a temporary vessel for ancient water, a small piece of the ocean walking on land. The very atoms that make up your body were not created on Earth. They were forged in the hearts of stars that lived and died long before our sun was born. The carbon, the oxygen, the iron, all of it was scattered across space in great stellar explosions. We are made of stardust, a collection of ancient atoms thinking about itself. The Earth has a certain brightness when seen from space. This is called its albedo. It is the measure of how much sunlight the planet reflects back. Bright clouds and ice are very reflective. while dark oceans and forests absorb more light. The Earth's brightness is always changing as the clouds shift and the seasons turn. A gentle flickering of a blue and white light. A river rarely flows in a straight line. It naturally forms gentle curves called meanders. The water flows fastest on the outside of a bend, eroding the bank. It flows slowest on the inside of the bend, depositing sand and silt. This process makes the curves more and more pronounced over time. A river's slow, winding signature on the land. Sometimes a river will cut across the narrow neck of a meander. This shortens the river's path and leaves behind a crescent-shaped lake. This is called an oxbow lake. It is a quiet, still body of water, a memory of the river's old path, a forgotten curve of a wandering river. The surface of a calm lake is a perfect mirror. It reflects the sky, the clouds, and the trees on the shore with perfect clarity. This stillness is a temporary state, a perfect balance between the forces of wind and gravity. It is a moment of profound peace in the landscape, the world looking at a perfect reflection of itself. New land can be born from the sea. Volcanic islands are formed when an underwater volcano erupts again and again. The lava builds up over thousands of years until it finally breaks the surface of the water. It is a violent birth that eventually leads to a new quiet place for life to begin. Fire from the deep creating a home in the water. The beautiful complex structures of coral reefs are built by tiny animals. Each coral polyp is a simple creature that builds a hard calcium carbonate skeleton for protection. Over thousands of years, millions of these tiny skeletons build up to create massive, intricate reefs. They are the largest structures built by any living creature, a city of stone built by soft, tiny beings. A spider's web is a marvel of engineering. The silk it is made from is, for its weight, stronger than steel. The spider spins it with an innate knowledge of geometry and tension. It is a trap, but also a beautiful, delicate structure, often visible only when the morning dew has coated it in tiny jewels. A net of diamonds in the early light. The transformation of a caterpillar into a butterfly is a quiet miracle. Inside the chrysalis, the caterpillar's body completely dissolves into a kind of nutrient soup. From this soup, new cells called imaginal discs organize themselves into the wings, legs, and body of a butterfly, a process of complete dissolution and rebirth. If you could gather all the ants on Earth, they would weigh as much as, or even more than, all the humans. These tiny creatures work together in complex societies. They build cities, farm fungi, and manage livestock like aphids. They are a silent, sprawling civilization under our feet. A small world of immense collective power. The grasses of the Great Prairies have a hidden strength. Most of their life is underground. Their roots can go down 15 feet or more into the soil. This anchors them against wind and fire and allows them to find water deep underground. The beauty of the prairie is mostly hidden, deep in the dark earth. A secret forest of roots in the dark soil. Deep within the earth, water can be superheated by magma. This creates immense pressure. A geyser is a crack in the surface that allows this pressure to be released periodically. The hot water and steam erupt in a powerful column. a temporary release of the Earth's inner heat, the planet letting out a deep hot sigh. For a fleeting second on some evenings, a flash of green light can be seen just as the sun disappears below the horizon. This green flash is a rare optical phenomenon. It happens when the atmosphere acts like a prism, separating the sun's light, and the green light is the last to disappear from view. A final emerald wink from the setting sun. The same gravity that holds you to the ground also holds the moon in the sky. The Earth is constantly pulling on the moon, preventing it from flying off into space. This pull forces the moon into a gentle, looping path around us. It is a constant, silent tether across 250,000 miles, an invisible chain holding our bright companion. But the moon is not just a passive partner. It pulls on the Earth too. Its gravity creates the tides in our oceans. It also creates tiny tides in the solid rock of the Earth, causing the crust to rise and fall by a few inches every day, a subtle flexing of the entire planet. The moon is slowly, very slowly, moving away from us. Each year, it drifts about 1.5 inches further out in its orbit. This is because of the friction from the tides. In the distant future, the moon will be smaller in our sky, its journey slowly spiraling outwards. A slow, quiet goodbye, measured in inches per year. The Earth has a shadow, and sometimes the moon passes through it. A lunar eclipse occurs when the Earth is directly between the sun and the moon. The Earth's shadow falls upon the moon, often turning it a soft, deep red. This red color is the light of all the Earth's sunrises and sunsets, filtered through our atmosphere and projected onto the moon. The shadow of our world, touching the face of the moon. Far above the weather, there is a layer of deep quiet. The stratosphere is calm and still. There are no clouds, no storms. Commercial jets fly in the lower part of this layer to take advantage of the smooth air. It is a place of thin, cold air and profound stillness. A silent highway in the upper sky. On rare summer nights, near the poles, you can see clouds that shine in the dark. Noctilucent clouds are the highest clouds in our atmosphere. They are so high that they catch the sunlight long after the sun has set for people on the ground. They are made of tiny ice crystals, glowing in ghostly, electric blue ribbons, shining whispers in the high twilight. Deep within the glaciers of Antarctica, there is ancient air. As snow falls and compacts into ice, it traps tiny bubbles of the atmosphere. By drilling deep ice cores and analyzing these bubbles, scientists can study the Earth's atmosphere from hundreds of thousands of years ago. A library of ancient air, frozen in time. In the deep silence of a cave, water can create jewels. A cave pearl is formed when water drips into a small, shallow pool. The minerals in the water slowly coat a grain of sand, layer by layer. The gentle agitation from the dripping water keeps the pearl round and smooth as it grows. A smooth, pale stone, born of darkness and dripping water. Our planet exists in a very special place. It is in the habitable zone around our sun, sometimes called the Goldilocks zone. It is not too hot and not too cold. It is just the right distance for liquid water to exist on its surface. This simple fact is what makes all of the life we know possible. A perfect, gentle distance from a star. And finally, remember the simple truth of this moment. You are on a planet, a great sphere of rock and water, covered by a thin veil of air. You are floating in the infinite, silent darkness of space, and you are safe, and held, and part of a slow, quiet miracle, a sleepy passenger on a ship of stone and sea. Our quiet journey through the wonders of the earth is coming to a close. We have felt the slow turning of the planet. We have heard the silent music of the deep, and we have touched the ancient stardust that makes up our world. Our home is a place of deep, calming rhythms, a living body in the quiet of space. If you enjoyed this quiet journey, I am glad you found your way here. It helps others find this peaceful corner too, one sleepy soul at a time. And now, just breathe, let your eyes close, and let the quiet turning of the world lull your thoughts to sleep. Good night.